Well, students, in this session I have brought certain problems based on design and selection of spraying equipment. Well, if you have gone through my earlier lectures, you will see that we have discussed various aspects of spraying equipment and parameters, there are testing, evaluation, etc. Now, I thought it was discussing certain numerical problems on that, and through that also you can clarify many doubts which you have in your mind. And I have come up with about 4 problems here, and we will see what are the requirements, how they have been answered, and later if you find that there is a problem in that, you can always approach and we will try to give answer to that. So, let us go through each of the problems, what is stated, what is given, and what formulae we have, how to use this formulae and how to get the answers. Problem number 1. See, if this problem here, a field sprayer having a horizontal boom of 20 nozzles are used at a spacing of 46 centimeter apart, is to be designed for a maximum application rate for 750 liters per hectare at 520 kilopascal and 6.5 kilometer per hour. This is a good design problem. In fact, you need to design a sprayer where there will be 20 nozzles at certain spacing, and then this is the 750 liter per hectare we require, and this is the pressure at which and the speed at which it must work. So, determine the required. So, for this what you will require, what is to be done. Determine the required pump capacity in liters per minute. Then assuming 10% of the flow is bypassed under the above maximum conditions. So, with the above data, what you need to find out, determine the required pump capacity in liters per minute. Then mechanical agitation, because this will be a long one and agitation is required. So, you need to know what is the mechanical agitation requires 375 input watt and the pump efficiency is 50%. What should be the engine rating if the engine is to be loaded to not more than 80% of its rated power. So, while in this particular design problem, these are details which are given, and you need to use your knowledge what you have learned so far to find out how they behave or how they actually perform. Then what discharge rate per nozzle, what is the discharge rate per nozzle is required under the above conditions. See, we have 20 nozzles at 46 centimeter apart, and with the given data, how much will be the discharge per nozzle, discharge rate per nozzle. If the nozzle have 70 degree spray angle, so you have seen that spray angle which we have discussed, if the spray angle is 70 degree and the pattern is such that 50% overlap is needed for uniform coverage, as we have talked that distribution of uniform coverage is very, very important. So, at what height above the top of the plant should the boom be operated? Very excellent problem so far as understanding a design of a good sprayer is. You have the sprayer, you have the conditions, you have been given nozzles, you have been given spacing of those nozzles, but certain aspects are given to see whether how do you check for the performance of this. Let us see how do we approach. The first is determine the required pump capacity. So, what is given here? In that, see the nozzles, as I said, we have been given to you, the nozzle spacing is also given to you, then maximum application rate is 750 liter per minute is given here. Now, this you can because you want to change it to hectare or per square meter, you want to check this, you can see this. Then operating speed 6.5 kilometer per hour, operating pressure which is also given 520 kilopascal. Now, determine the required pump capacity in liters per minute. How will you get this? Assuming 10% of the flow is bypassed under the above maximum conditions, 10% of the flow is bypassed. So, what will be the required pump capacity? Now, we need to know what is the pump capacity without losses straight away. maximum application rate into area covered will give you. So, you have the maximum application rate here, the number of nozzles and number of spacing and speed. So, when you get these things, definitely number of nozzles, spacing and the speed will give you how much you have got area covered. So, area covered will give you from the number of nozzles, the spacing and the speed at which is moving. So, per area covered per unit time you will get from here, and the maximum application rate which is already given to you, the maximum application rate which is given to you, then this information is multiplied by this, which you get about 75 liter per minute this. So, the pump capacity without losses is 75.75 liter per minute. Now, consider 10% loss by bypass, that means this is bypassed, then what will happen? The pump must give more than this, because there will be a loss of this. So, just increase by that much, that means say 1.1 times that value. So, this is the value which you are going to get. So, you understand that given everything, how do you approach? Two aspects, pump capacity is needed. So, maximum application rate and the area covered. When you want to find out the area covered, you must know what is the number of nozzles, spacing of the nozzles and the speed at which they are moving. So, you will be able to know what is the area covered per unit time and the application rate. So, then you will be able to know how much is the requirement when there is no loss from the pump which you require. But when it is said that 10% is getting bypassed, well, you have to increase that amount. Actually, we get this. Second aspect, mechanical agitation requires 375 input watts and the pump efficiency is 50%. Pump efficiency is 50%. What should be the engine rating if the engine is to be loaded not more than 80% of its rated power? Very nicely worded problem. See, you are talking of the power BHP of that. Now, the pump capacity and the operating pressure, this gives of the power. So, the pump capacity is you have already found out from the other side, and then what is the operating pressure which is mentioned 520 kilopascal already mentioned. So, taking care of the units, what you get is this kilowatt, this is the power. Now, pump efficiency, how do you say pump efficiency? The output by input is giving you the efficiency. So, the actual brake horsepower is theoretical brake horsepower by pump efficiency. This is what you get, because what is given here is 50% is the pump efficiency is only 50%. So, with respect to that, what do you get? The actual brake horsepower is this. Then the net power including agitation, how much will be the net power including agitation? Because for agitation you are requiring certain amount of the power which is this input. So, if we put this 375 watts, so 0.375 kilowatt. So, this kilowatt plus this, that means the total net power including agitation is 1.180. Now, brake horsepower of the engine will be, because this engine as such, the engine rating, if the engine is loaded 80% of its rated power, it is working at 80% of rated power. So, this has to be, so 1.801 divided by 0.8. So, this is the power. So, that means at least 2.25 kilowatt should be the power. What should be the engine rating? The engine rating should be this, because it has 80% rated power is being used. So, this is the value which comes. You only need to understand the aspects which are asked and then follow. What discharge rate per nozzle? Well, is required under the above condition. It is very important. What will be the discharge rate? Discharge per nozzle, how do you get? Total discharge by number of nozzles, definitely. So, this is what you have got, discharge per nozzle. Then if the nozzles have 70% spray angle, now the spray angle this is called the spray angle. You can see this is the angle which is known as the spray angle. This spray angle is this spray angle, this is what it is, this is about 70 degrees, this is spray angle. The pattern is such that 50% overlap. So, it says that 50% overlap is needed for uniform coverage. What is this? spray pattern 50% wider than the nozzle spacing. This is the meaning of the overlap that we are talking with respect to this. So, when you have this, at what height above the top of the plant should the boom be operated? Now, once this is known to you, you can see that as if there are 3 nozzles, one nozzle is here, the other nozzle is here, the other nozzle is here. So, the spacing of these, now you can see that one nozzle has a coverage area like this, the other has a coverage area from this to this. And now, how do we approach this? You see, here's, if you drop this here, you get you get this angle, which is 35 degrees. So, with this, and if this is the d is the total diameter or the width which has been covered. So, d2 will be up to this. So, now we have said that the 50% wider than the nozzle spacing. Nozzle spacing is 46. So, what do you get here? The coverage which is in the overlap comes, this is equal to this. Now, if you have this, so this and this can be found out. Now, if this is known, this d2 is known to you. So, tan 35 will be nothing but if you are talking with respect to this, what you get tan 35 over is 11.5 by h, if this is the h which we are talking with respect to this. So, this is 70% here 70 degrees and this is 35 degrees. So, this is the one which we are talking is half of this. Now, you get h, this h as this. So, once you get this h, now you cover these ones, because this is the h which is capital H here. So, this if you take the triangle, if you are talking of this triangle here and this triangle which you are talking with respect to this triangle, this one here. So, what do you get is h by h. Now, this is the height a here, this is the height here h. So, this by this, if you are talking of this, that means what you get is 23 plus 11.5 here in this case, this will be here, and then h, this is h here corresponding to, and this h will correspond to this 11.5. So, the h value you can get, because small h you have got from here. So, bigger h you will get from here. So, that means the height should be at 49.27 centimeters above the boom should be operated. So, this is how we get. Now, these I have explained these. If you have further questions, you can always ask us, and we will like to clarify, but this is worth understanding how to design a new system. So, the results I have already said, these results if you put them together at one location, the required pump capacity is 82.225 liter per minute, engine rating or the brake horsepower should be about 2.25 kilowatt, then the discharge rate per nozzle is 3.75 liter per minute, and then the height at which 49.275 centimeters. This is the result which we got from the previous one. It was a good design problem. Let us see another problem considering some other aspects of the design. An air blast. Well, we had talked of sprayers and where now pressure, and here air carrier sprayers where air blast is there, and which we are atomizing the particles. So, it is good that a problem like this has been taken, and I am sure you are aware of this particular device which we had shown you earlier. This equipment has been shown to you earlier in the lectures, if you have seen those lectures. So, an air blast sprayer is to be operated at 4 km per hour, and the desired application rate is 19 liter per tree. So, the tree spacing is 9.9 into 9 meters. That means, the spacing on this way, I mean when you are talking of this. So, maybe one is here, the other is here, and here, and is here. This is what it talks of, this 9 by 9, and each nozzle delivers 4 liter per minute, and the operating pressure is 415 kilopascals. So, if what is asked, if 1/2 row is spread from each side of the machine, how many nozzles will be needed? Now, you can see here that in fact, this is exactly done here. You can see that there is no plants here, but this is on plants are only on this side. So, if only this side is to be spread. So, how many nozzles will be required? And definitely when it goes into an orchard, then on both sides there will be the canopy. So, it will have to have a spray on both sides, and hence once you know on one side, you can just double for the other side. So, how many hectares can be covered if there is a 2 meter cube tank full of spray? This is another aspect which is asked. Now, let us see how will you approach. What is given to us? The spacing, that means distance between one tree and another tree is given. So, operating is what is given here? Already 4 km per hour speed is given, which can be changed to 1.11 meter per second. Application rate is 19 liter per tree. So much of you have to apply. So, you must know how much time the nozzle must be sprayed, so that you get that much. Then the tree spacing, as I showed here. Then the discharge per nozzle is given here. The operating pressure is given. So, once you have this, the details, you use this given details into the problems that you know, the formulae that you know, the expressions that you know for finding out the details of finding out the total number of nozzles or the nozzles required, the specification, spacing of nozzles and pressure, etc. So, if one row is spread from each side of the machine, how many nozzles will be required? Let us say that only n is the number of nozzles on one side, let us say. So, if net discharge on one side will be, because 4 is coming out from one nozzle. So, n into 4 will give you total this much. Now, if T is the time for application to each tree, you know that 19 liter is required. So, 4 into n into tree, this is the amount which is per tree, and you know that this is equal to the time of application is given. So, then the T is the time of application to each tree. Then what you get? 4 into n, which is the net discharge, and n this much time. So, what is so much liter per tree is the one which you get. Since T is also equal to equal time to move 9 meter, sure. So, in this time it has moved from one to another one, that is. So, during this period, see how much time it has taken. See, S is equal to V into T, where T is nothing but S by V, the distance by the velocity at which it is moving. So, what do you get here? The 19 liter is equal to this. Therefore, N is equal to 35.18. It is very simple. Now, it says that about 35.18 nozzles will be required. Now, you should not take less than 35. So, definitely 35 cannot be said at 36, but then you will have to go for 36, because the minimum is this. So, you will have to go, and therefore, the answer is that one side at least 36 should be there. And then when you talk of the other side, so the system will have therefore on both sides. We will not like to have only nozzles on one side, you will like to have nozzles on the other side as well. So, 72. So, this is what is the answer for that. How many hectares can be? Very simple. If you know that 2 meter cube tank is full of spray, the total discharge, how many you discharge one nozzle, total number of nozzles are known to you. So, 72 nozzles, and this is the discharge. So, total this is the value. Now, time required for this, now chemical to be utilized is 64, because you know that how much is the discharge what you require and how much is already in the tank. So, on that basis you require that it will take about 6.94 minutes, just by ratio will give you. So, the total area covered during this period, what is the area covered? Because you know the speed at which it moves. So, you should be in a position to find out, because this is the one and this is what you get the distance covered, and this is the rate at which it is moving. So, you can get this, and hence this much area. So, the answer is 72 nozzles and this much hectare. So, if you have 2 meter tank full spray here, it will cover about 0.42 hectares. This is what it says. Another problem, a very simple problem, but then it requires you to remember some of these formulae which we had talked of, particularly with respect to agitation, mechanical agitation. So, this talks of mechanical agitation, a round bottom sphere. Well, this you need to take this to be a round bottom one. Round bottom, 1.5 meter long and has a depth of 0.9. So, other details for remaining already. Mechanical agitation is to be provided with 4 paddles, yes, 1, 2, 3, 4 paddles, 280 millimeter long and 200 millimeter wide, mounted on a shaft 150 millimeter above the bottom of the tank. So, this distance is known from here to this distance is known to you. Then calculate the minimum revolutions per minute for agitating a mixture of 10% oil and 90% water. And mechanical efficiency of the power transmission is 90%. What input power would be needed for this particular agitation? Well, these are already given to you. So, let us see how do you proceed. In fact, here hardly anything is required. What is required is you need to remember those empirical equations which the researchers have found out regarding the details of the paddles, the spacing, location of the paddles and the width, etc. See, so the minimum revolutions per minute for agitating a mixture of 10% oil, 90% water. This is given to you already, this formula is given to you. So, A is the depth of the tank, location of shaft above the bottom of the tank, then minus location of the shaft. So, what you get is 0.9 minus 0.15, because location of the shaft above the bottom was given already. Then A is actually 0.75, this A is here. A is raised to 0.422, this you need to remember. R here, this R is the total combined width of all paddle by length of the tank, very important. This is raised to minus 0.531, this you need to remember. This is what you need to remember, because these are empirical equations and they have been found out with large experimentation. So, you need to understand this and have maybe you need to remember that length of the tank. So, this is R which you get. So, you have got R, you have got A. Now, Fe, you need to get Fe, where it is, this is a value which will be available. Now, let us so Fe. Now, Fe agitation factor. So, the agitation factor here Fe agitation factor is taken from the table is 0.89. If it is not given in the formula or in the problem, you need to take from the table here, and these are maybe we had given you earlier what is this emulsions are there. So, this has been given. So, from there you need to take them and put these values as you can you got for A, R and Fe, and using these then you get Sm is so much meter per second. So, the volume of the tank V is pi d square by 4 into L, simple. So, this is known to you. So, you can get what will be the diameter of the tank, this is the diameter of the tank, and Sm then is pi dn. So, you know the pi dn, Sm is already given to you here. So, you should be in a position to know how much RPM, what should be the revolutions per minute. So, simply you get this revolutions per minute here. So, by this you are you can use, see this is also we want to clarify better what we have taught you or shared the knowledge, particularly with respect to sprayers and dusters and their details. So, with these numerical problems, we are trying to clarify more details. If you have further information which you need to know, we will be happy to answer those at some point of time when it is required. If the mechanical efficiency of the power transmission is 90%, what input power? Well, for input power of an agitator, this also is given to you. So, you can use that R, Sm and L. SM is you have got it already, R you have got already, and L is given to you. So, using this is the one which you get from here, but the mechanical efficiency is only 90%. So, this has to be enhanced to 90%. So, it comes to about 4 or 5. So, ultimately these are the things which were asked of you, and you have to using these you are in a position to find out the details of the problem which was presented to you. Let us take another problem. Well, it is worth showing you this, because this is a problem which has been talked of with respect to one aspect of the volume median diameter, and it is very straightforward problem. Although to you, once you have not seen the solution, to you it will appear that it is very difficult. Now, what is asked here is, a manufacturer of pressure nozzles specifies that a volume median diameter is 135 millimeter, is obtained at 345 kilopascal using water. The same nozzle is to be used for a chemical whose surface tension is a certain value. So, determine the volume median diameter of droplet size if the nozzle is to be operated at this. Now, tension remaining same here, what do you get? Volume median diameter is this. Volume median diameter is this which is given. Pressure of nozzle using water is given here, then surface tension is given here, then pressure of nozzle using chemical is also given here. So, the relationship which is known to us, you should go for the relationship. If you have gone through the details of the sessions which I had earlier, then you will be able to get this. See here how it is connected. The surface tension of the chemical is given here, and then this is the dVm and dVm water and dVr chemical. So, they are in these relations are nothing but this with respect to these here. Now, this in fact this is wrong, this should be 1/2 here. So, the value is 0.83. So, you get the value and determine the volume median diameter 0.83. So, let us see what else you how do you get the details. So, you had got this volume median diameter d1 by d2, this was given to you. You might have checked, this is of hole actually 1 3 here. So, okay. So, this is what you get. So, VMD2 is VMD1 by this. So, VMD1 was given to you. So, VMD2 is just this is the value. So, VMD2 of the chemical will be this times of water, VMD of the chemical is this time of equal to this. So, the volume median diameter of chemical droplet is 97.43 millimeter. This is how, very simple, only thing you must have your concepts clear so far as the volume median diameters are concerned. And I think through these 4 problems, what we have discussed is we have enhanced your knowledge related to the sprayers and the details of sprayers, what is the pressure maintained, what is the overlap, what is the nozzle spacing, how do you test them, and how do you find out the different parameters. You need to of course, as we see in one of the problems, you need to remember some of these empirical equations which have been developed by the researchers. So, with these 4 problems we have tried to enhance your knowledge related to this. Maybe we will pick up a few more problems in this regard and see that you are very well equipped with the knowledge related to the spraying equipment and application part of it. And if you have any questions, we will definitely like to answer them as and when they come, and we close this at this point of time. Thank you very much.